Good evening, everyone. Thank you for being here today. Our team will be presenting a bridge structural health monitoring system, a simple yet effective Python-based simulation designed to assess the condition of a bridge using input vibration, strain, and temperature sensors. There are three goals for this system. The first one, to detect early sign of structural damage. The second one, to recommend appropriate maintenance actions based on severity, and the last one is to evaluate the cost effectiveness of developing such a monitoring setup. We've broken the system into 5 core parts, and each of us will explain one section, starting from how we collect the sensors data, process and evaluate, generate recommendation, compute cost, and finally tie everything together into a complete report. Let's start by looking at how the system gathers sensor input and how it determines the setup configuration. Sensor input and configuration. This section covers the setup stage of the system. It does 2 key things. First, we define the unit cost of each sensor type using dictionary. Vibration sensor costs $50 each, strain sensors cost $80 each, and temperature sensors are $30 each. These values are used later to compute the total sensor installation cost based on the user's configuration. Then we have the get sensor quantities function, which asks the user how many sensors are installed for each type. This is important because it makes the system flexible. We're not hard coding the setup, we're letting the user specify how the system is deployed. The get sensor data function follows, where the user inputs real-time readings from those sensors, vibration, strain, and temperature. We include validation. For example, vibration must be within realistic range to ensure data quality. So this part is about capturing a real-world condition and installation context. The what's on the bridge and what is it sensing right now.
So for the next part is severity evaluation. This section processes the sensor readings and turns them into a numerical array score. The evaluate severity functions takes vibration, strain, and temperature and compares them to define safety thresholds. For each reading, we assign a score. Vibration above 8 gets 3 points, above 5 gets 2, and so on. Strain above 1200 gets 3 points. This means the structure is deforming too much. Temperature above 70 degrees Celsius also raises concerns due to material expansion. These individual scores are added up to get a total severity score with a maximum of 8. This part translates raw data into a meaningful indicator of how healthy the bridge is right now.
Okay, so after we calculate the severity score, we then pass it to the maintenance recommendation part. So here we have defined maintenance priority. So this function interprets the score into an action, where something that engineers or maintenance teams can use immediately. And the logic is very simple. So if the score is 6 or more, we recommend immediate maintenance where the structure is likely at risk because it's high priority. And then if the score is between 3 and 5, which is still below 6, it's a moderate alert where something should be scheduled soon or maintenance soon. And if it's below 3, it means that the bridge is currently in safe condition or low priority where no immediate action is required. And basically, this part turns the severity score into a easy, clear and easy to understand decision.
on to the next, I will explain about the cost evaluation. So this section looks at the financial side of the system. The function calculate sensor cost dynamic multiplies the number of each sensor installed from the earlier input by its unit price. So this gives us the total cost of the monitoring system for each current bridge setup. Then, cost effectiveness message gives a judgment about whether the sensor cost was worth it. For example, if the score is low, the sensors are working. They've helped prevent the problems. And then, if the score is high, it shows that even more serious issues were caught earlier, making the investment worthwhile. This also helps us by justifying why the system is valuable, both technically and also economically.
Okay, so now the main integration logic. Finally, the main function brings everything together. Here's the overall sequence. We ask the user how many sensors are installed. Then we collect the real-time sensor readings. Next, we calculate the severity score and determine the maintenance priority. We calculate how much the sensor costs. Then we generate a message to explain whether that cost is justified. And finally, we print a clean monitoring report. This function ensures that the entire workflow is seamless, from setup to data input to risk analysis to final report.